How you going, guys? Curtis from Cutting Edge Engineering. So today is going to be our final part on our tool post grinder build, where we give this a test run, give it a paint job, do the final assembly, and give you a demonstration. So if you've missed any of the videos of this project, we'll leave a link in the description below. The first thing I'm going to do is plug the VFD onto the motor and make sure everything works correctly. So because I've never had to use VFDs before, I'm not very familiar with them. So I did get Troy to help me because he does have a lot more experience in that side of it. So what we ended up choosing was a VVOR VFD. They are cost effective and readily available. The one we got is a 4 kilowatt 3-phase unit. It runs 240 volt in and 3-phase out, which gives us the full control we need. Troy's done some bench testing with the motor to program the VFD, so it is running efficiently and we have a benchmark for speed and torque. We also got a lead wired into the VFD and a longer extension lead wired into the motor, so the VFD can be kept away from the working area and it doesn't get wet or damaged by coolant. So this is ready to be plugged in and we can see how it runs. Now that's connected, we're going to turn this on and slowly wind up the RPM. That is running really nicely. It looks like the sweet spot is about 1100 RPM on the dial, which I know converts to about 3500 RPM at the spindle shaft. Because the stone isn't dressed or balanced and they are rated for a certain speed, you don't want to exceed that because they can fly apart. So I'm going to remove that and wind this up to the maximum speed it's been programmed for. So that's maxed out to 1500 RPM on the dial, which converts to about 4000 RPM at the spindle. But I do know the VFD can run much higher, but we have set a limit so we don't damage the motor, damage bearings, or the stones fly apart. That little rattle you can hear is the belt touching the spacer tube for the guard. The reason that is happening is we haven't tensioned up the belt yet. So I'm really happy with how this works, but I don't like the VFD just sitting on the bed like this. So I think I am going to make a bracket so I can mount it up beside the digital readout and it'll be out of the way. But now we can get this disconnected and get this ready for painting. Something I've already done is stamp numbers into the spindle clamps so I don't mix them up. I've also changed out the threaded rod to Allen head cap screws to hold on the guard. And I'm also going to drill and tap 2 holes in the top of the mount so I can attach some lifting eyes. So we're going to get this disassembled and set up in the mill. Now that that's drilled and tapped, we can take it outside so we can paint it.
This wind's crazy.
think I got it off.
Where is he?
What is that?
It's, you're meant to put treats in it.
Oh, yeah?
Good boy.
Righto guys, so that's our motor and all of our parts painted. Everything's turned out really nice and I can't wait to get this reassembled. But something that did slip my mind was a guard to go around the grinding wheel. It was actually a YouTube comment that reminded me about it. So while we were waiting for these parts to dry, I did go ahead and get that made and painted as well. Now we've got all these parts completed and dry, we can get it reassembled. So I'm really happy with the paint scheme. It does go along really well with all of our other workshop projects. You may have noticed I haven't painted the spindles or the spindle housings. The reason for that is it would change the tolerance and it would just get scratched up. We also considered bluing it, but that wouldn't stop it from rusting. I also looked at the tough tried treatment, but because that uses heat, that could change the shape of the material or bend the spindle shafts. So we're just going to leave it bare metal and just put oil on it when we're finished, and over time it will get a really nice patina on it. Righto guys, so that's our tool post grinder completely assembled. I'm really happy with how this turned out. It looks awesome. So the next thing we're going to do is plug in the VFD so we can give you a demonstration. So the first thing I'm going to do is turn this back on and run it up to speed. Because it's been reassembled, I want to make sure everything's in alignment. So that's running all correctly. We are getting a little bit of a squeal coming from the belts, but V-belts tend to do that sometimes. And because they're brand new, it will take a little bit of time for them to wear in, but it is something I will keep an eye on. So now what we're going to do is get our grinding stone running through. And to do that, what I'm going to be using is a diamond dresser. There are many ways to set these up in order to true up your stones, but the way I'm going to do it, I'm going to use the boring head out of the milling machine to hold onto the diamond dresser, fit that in the chuck, and then I can true up the stone. So another pretty important thing to keep in mind when you are using a tool post grinder, you do need to cover up your bedways so you don't get grinding dust on them. Because it is an abrasive material, if it gets under your way wipers, it will grind your bedways and damage them. And I'm also going to be running coolant when I'm dressing the stone, and that will just help suppress a bit of the dust. So that's our grinding wheel dressed. I ended up taking about 2 mil off the diameter in order to get that to clean up. Now we can set up a piece of material that we're going to be using for doing the demonstration. And the piece of material we're going to be using is a offcut of 75 mil 4140 solid bar. Righto guys, for a first test run, that has worked exactly how I wanted it to. It has left a mirror finish. It is as smooth as chrome bar, which is exactly what we're looking for. But one thing I did notice, when I took the first cut, I did hear a little bit of a load go onto the motor, which is just a setting in the VFD, so that's something I'll get Troy to adjust. But for what this is designed for, which is achieving tight tolerances and really good surface finishes, this is exactly what we wanted. But I did also design this for doing something else, which is linishing and polishing cylinder rods. And that was by making the spindle shafts 1 inch to suit the linishing and polishing wheels we can get. So we're going to get the grinding wheel out, get a linishing wheel set up so we can polish some chrome. Something I've noticed is when using these linishing wheels, they work best on a slight angle, not 90 degrees on the job. So I'm going to angle the tool post grinder slightly, and that's the reason why I didn't put an alignment key to hold it 90 degrees with the bed. Yes, you could just angle the top slide, but because you need to redress the stones every time you take them off the grinder, there wouldn't be any point in that. So that worked really well. That polished up that chrome really nicely. With a bit more dialing in, like speeding up the headstock and spinning the part a little bit quicker, we'd probably achieve a much nicer surface finish, but that is more than enough for what we're looking for. So that's the demo completed on our external spindle. Now we're going to set up the internal one and give that a test run. Righto guys, so that was a pretty aggressive first test of our internal spindle. I do have a pretty aggressive stone on here, and that is an interrupted cast iron piston that I'm grinding. All in all, it worked out really well. If I was to put a finer grit stone on there, I'm sure we could achieve a really nice surface finish, but what we've got in there is more than acceptable for what we need this for. And the sorts of jobs we're going to be using this on, there are some cylinders out there used for porta powers that cannot have a honed finish in it. It must be a ground finish to meet a certain RA level. So this is going to work perfectly for those sorts of jobs. This was a really successful test of our tool post grinder with our internal and external spindles. I'm really happy with how everything's turned out, and this was a very enjoyable project to build. So we're going to give you a breakdown on what it cost to build this. The plates to build the mount and the spindle clamps were $1,000. The material to build the spindles was $540, and that included all the bearings. The pulley system was $170. The pulley guard was $30. The motor was actually free because I got that given to me, but if you were to buy one, it'd be about $450. The VFD was $180, and then about $50 for miscellaneous bolts and paint and stuff like that. So all up, this cost us $1,900, not including the motor or my time. This was well worth the investment to build something that I cannot buy, and this is another service we can offer to our customers. And now that I've built this, if I was to build it again, there wouldn't be anything I would change because it functions exactly how I wanted it to. Aesthetically, you could go and change the clamp design to make them look a bit nicer, or even the guard or another way of holding it on. But considering this is the first one I've built from scratch, I'm really happy with how it turned out. So I really hope you enjoyed seeing the build of this project, and you'll probably see it being put to use on a future job. Thanks for watching.
You know how you just went and got your safety glasses because you couldn't find yours? It's a pile. That's Curtis all over right there.
I was like,
where are they? They're not on my head, they've gone.
so we're going to get the grinding stone out, get a wheel set up, and polish a rod. So I'm really happy with how this, So I'm really happy with how, this or that. So I'm really happy with how this runs. One thing I need a moment. Words. So we're going to...
What is going on? How many coffees have you had?
About fucking 6. My brain's just going. We also got a lead wide into the but I did also but you could, how do I start it? How do I start it?
But,
That sounds just like me. Oh my god. I know. Fuck, I can't even get words out. Just let me say this my way.
Sure.
Alright.
That sounds exactly how you normally sound.
Are you ready? Are you ready?
Yes. Yeah, I could. But do I want to do that? No.